Hello everyone, welcome to Clean Coder YouTube channel. So if you haven't subscribed to my channel till now, I'll highly recommend you to subscribe to my channel as I make tutorials related to data structures and algorithms, software engineering and system design. So the topic of today's video is strategy design pattern. So we have already made an introductory video to the design patterns, and we already know that design patterns fall in three categories. One of them is behavioral design pattern. So this design pattern falls under the category of behavioral design pattern. Now let's check out the definition of this design pattern. So the definition is the strategy pattern defines a family of algorithms, encapsulates each one, and makes them interchangeable. Okay, let me go through this again. The strategy pattern defines a family of algorithms, encapsulates each one, and makes them interchangeable. Strategy lets the algorithm vary independently from clients that use it. So strategy pattern lets the algorithm vary independently from the clients that use it. So this is the definition of strategy design pattern. So these design patterns, and particularly strategy design pattern, is based upon these two design principles. The first one is favor composition over inheritance. Composition means has a relationship, and inheritance means is a relationship. So it says that whenever and wherever we can, we should favor composition over inheritance if there is a choice, because composition allows greater flexibility. And the second design principle is program to an interface, not an implementation. Implementation here means concrete class. Okay, we should not program to concrete class. We should always program to an interface. This is what the second point talks about. Let's check out the third point. Third point is identify the aspects of your application and separate them from what stays the same. Okay, this is nothing but this points to like separating the constants from the variable. Like what remains same, we should separate that out from what varies or what changes. So these are the design principles over which these patterns are based on. So now let's check out an example of strategy design pattern, like uh, an example which covers the design pattern in depth. So let's see the UML diagram of this design pattern. So this example I have taken from Head First Design Patterns book by Eric Freeman and Elizabeth Robertson. And this is a pretty good book, and this example is really a good example, and no problem, I'll go through this example in depth. So what this example says that we have a duck class. This is a abstract class basically. So we have some behaviors which ducks have. Now all the ducks have some common behaviors, and some behaviors are particular to some particular ducks. So this is the gist of this overall example. So all the ducks have fly behavior, and all the ducks have quack behavior, right? So these fly behavior and quack behavior, these are the two interfaces, and our duck has fly behavior and our duck has quack behavior. So this is clearly a has a relationship. So let's check out these interfaces also, fly behavior and quack behavior. So This is the interface fly behavior. Now fly behavior interface has a method fly, which is overridden by the concrete classes which are implementing this interface. Okay, fly with wings is a concrete class which is implementing this interface fly behavior. So its fly will have its own implementation, something like implement duck flying. Okay, similarly there would also be ducks which don't fly, right? So it would have their own implementation, like do nothing, can't fly. So this is the fly behavior. So ducks also have quack behavior. So this is the interface related to quack behavior. So the ducks can either quack or they can squeak, or there could be mute quack also, right? Some ducks don't quack at all. So this quack methods, each concrete class which is implementing this interface would have their own implementation. Like quack would have something similar to duck quacking, and squeak would have something similar to rubber duck squeaking, and there could be mute quack as well, which do nothing and like they can't quack at all. So these are the two behaviors which our client or the duck class has. Now there are some features or some behaviors which are common in all the ducks. Like all the ducks swim, right? uh, all the ducks have a display, or they have a representation, right? But like there are some particular things like how they quack and how they fly which are behavior dependent, like how the duck quacks and how the duck flies. So these are the two methods which using which will have that behavior in our duck. So there are setters also using which we can set concrete fly behavior and concrete quack behavior. So there would be other duck-like methods also in this abstract class. So this abstract class we need a concrete implementation. So we'll have a duck, like a mallard duck, which is a duck. This is a relationship, and its display would be its own, like it would be particular. Rest of the part would be same. So it would look like a mallard. Similarly, there would be a red hat duck. It will look like a red hat. Similarly, there would be a rubber duck. It will look like a rubber duck, right? So display method would have its own implementation. This is particular to those particular ducks. So this would be overridden. So this is the basic example of the strategy design pattern. This is taken from Head First Design Patterns book. So if you want more clarity, you can refer that book. But I would say like this is a good example to understand this design pattern. So let's check this example in code also using Java programming language. Okay, so this is the duck class, duck abstract class which we have, and it has two kinds of behaviors. One of them is fly behavior, and the second one is quack behavior. And we have a default constructor, and we have a abstract method display, which would be implemented in the concrete duck class. So the behaviors which are common in all the ducks are they fly and they quack, right? But like the actual behavior or the actual algorithm using which they fly or quack, we can choose that at runtime using setters. Like these are the two setters using which will pass the behavior, which kind of flying behavior we want and which kind of quack behavior we want. And again, this swim is common to all the ducks, like all the ducks swim. So we are directly printing this on the console. This is the duck abstract class. Let's check out the fly behavior interface. So fly behavior interface has only one method, which is fly. Let's check the concrete implementations which are implementing this interface fly behavior. So there are three concrete classes: fly no way, fly rocket powered, and fly with wings. Let's take an example of fly no way. Okay, so this is just overriding the fly method, and it's printing to the console I can't fly. Similarly, uh, two other classes have just the console output difference, and rest of the stuff is same. So I'll skip those. So let's move to the quacking interface, quack behavior interface. So this quack behavior interface has a method called quack. So the concrete classes which are implementing this interface are again three. There could be either a mute quack or a quack or a squeak. So let's check out what is a mute quack. So mute quack is nothing but like just printing silence over the console. Similarly, the other two classes have a different print message in their quack method. So I won't be going through them. So these are the two interfaces. So now let's check out the concrete implementations of duck. Like there is a mallard duck and a model duck. Let's check out what is a model duck, let's say. So this is the model duck. So this model duck is extending the duck abstract class. So it has everything from the duck class, and we can provide the fly behavior and quack behavior, like how this duck should fly and quack. So that behavior by default we are passing in this default constructor as the fly behavior would be fly no way, and quack behavior would be simple quack. So you'll see that this could be overridden at runtime using the setters which are there in the duck abstract class. So this displays the overridden display method, and it just prints out I am a model duck. So this is the concrete implementation of a duck, model duck. So let's check out the main method now. So this is our main method. So we have a duck, model duck. We are creating its object. So by default, you see that the behavior of flying the behavior of flying of model duck is fly no way. So uh, the met so the message which should be printed would be I can't fly. Okay, so this message would be printed in this snippet. So let's check out whether this is getting printed. Okay, this is getting printed. I can't fly. So let's modify the flying behavior at runtime. So what we'll do is we'll set the fly behavior to something as fly rocket powered. So what does fly rocket powered would do? This would override the fly method, and it would start flying. Like this message should get printed, I am flying with the rocket. So the strategy of flying, or the strategy or the behavior or the algorithm got changed at runtime. So let's see what is the final output now. Oh, so you can see the strategy got changed, and it is printing I am flying with the rocket message on the console now. So that's the beauty of the strategy design pattern. That is, you can give the behavior or the algorithm at runtime, and it just changes that behavior, and you can see the results well. So let's return to our slides now. So this is the UML diagram demonstrating the strategy design pattern. So I think this should be clear now. And if you have any doubts related to this example or this strategy design pattern in general, please feel free to add that in the comment section below. So the next thing is, let's check out the examples of strategy design pattern in Java programming language. So if you have sorted an array or anything, any object or like any collection you have sorted using collections.sort, then you have already used the strategy design pattern because it gives you the flexibility to provide the algorithm or the strategy at runtime. So strategy design pattern is really useful, and it's used a lot in Java core libraries also. So that's all I wanted to talk about in this video. So I have taken the example from Head First Design Pattern book, and you can refer this book if you want more clarity of this example and better understanding. So thanks a lot for watching this video, and do subscribe to my channel, as I'll be making tutorials related to all the design patterns which are heavily asked in the interviews. So thanks a lot for watching. Hey guys, do check out this Instagram channel, Clean Coder Community, for all the jokes and memes related to software engineering. Thanks a lot.